section 2.2 here, I have 3 examples set up to do for you for this video. We'll just do the first 2 on this set of the video, and then we'll do the third one on a separate one. So that way you can choose what information it is that you need extra help on if you want to watch them all or not here. So our first one here, for example 1, is to construct a stem and leaf plot. So once again, like whenever we're doing our frequency distribution in the last section, we want to first of all reorder these numbers. So we want it to be from smallest to largest here. So to relist that, we just start with the 2 and then go up to the 38, which is the largest number. Make sure whenever you are relisting them in order on your own for your problems, make sure you do get all the numbers accounted for. A good way to do that is to count to make sure you have the same number of values in your list as what there was to begin with. It's easy to accidentally forget a number or miss it whenever you're trying to get them back in order. So after you get them listed in order, to do your stem and leaf plot, the stem, whenever you're dealing with a 2-digit number anyway, has to do with the number that is in the tens digit. If there is no number in the tens digit, for instance the 2, then you would have a 0 for the stem there. So for those 1-digit numbers, we'd have a stem of 0, since there's no number in front of those. And then for the tens digit that has the 1, we'd have a stem of 1. So the ones that are in the teens there, we'd have a 1. The ones in the 20s, we'd have a stem of 2. The ones in the 30s would have a stem of 3. Keep in mind also that depending on how many numbers you have, for instance, if you had a large set of numbers, maybe you had 50 numbers or something, you could split up these stems as well. You could do 2 zeros, 2 ones, 2 twos, and 2 threes, and split up the leaves from there. Just want to make sure you're setting up a key if you're doing it differently than what you would do normally. So here, for instance, if we had a 0 and then the line and then a 5, that represents in this case the number 5. So this would be what we call your key for what your values are representing in this table. So here then for your leaves, that has to do with the numbers in the ones digit in this case. If you had a 3-digit number or something instead, then it'd be that last digit. The leaves always have to be just a single digit. The stem could have 2 digits or more, but the leaves always will only have 1 digit included. So in this case, the leaves here, we'd have a 2, a 5, and an 8. For the stems of 0, for the stem of 1, we'd have a 2 to represent 12, a 5 to represent the number 15, 7 to represent the 17, and 9 to represent the 19. The numbers in the 20s, we have a 20, so we'd have a 0 there. Make sure to keep in mind that if you put a 0 in the leaf, that means that you had a number that corresponds to that. So if you happen to have a stem that has no leaves, that it had no numbers, for instance, that were in the 20s, you would leave it completely blank. If you put a 0 there, that means that you had that number 20 as one of your values. So something to keep in mind, and if any of your values are skipped over for your stems or your leaves there. So then next we'd have 2 2s for the 22s. There were 2 of the 22s. Then we had 23 and then 25. So those would be our leaves there. And then for our 30s, we have a 0 for 30, a 2 for the 32, 3 for the 33, 2 5s for the 35s, and then a 7 and an 8 for 37 and 38. And this is what's called your stem and leaf plot. And you can choose here whether you want to put commas in between those leaves or not. Normally, you'll see it without, but you can definitely put commas in between if that helps you to keep them organized, to remember that those are each representing a different number there. But you don't have to, you can just list them, and you can write out what your key is. The key you don't necessarily need if it's just a 2-digit number, but if it was a 3-digit number or more where it's something different for your key, you definitely want to make sure that you have that set up, so that way it's easy for your reader to follow what it is that you're talking about there. Or in this case, it'd be easier for me to figure out what you mean on a test or a quiz. Then our next problem is related to this one that we just said. It's doing your dot plot. So a dot plot isn't too difficult to do. You do want to make sure that you include a scale whenever you're doing these. So here, for instance, we could start at 0 and we could go up by 5s, for instance. Or you could go up by 10s, whatever you think is easiest. Just want to make sure that you're being consistent whenever you're setting these up. You're going up by the same amount, and that they're all about the same width, just like whenever you're doing the graphs earlier with the frequency histogram in the last section. So we go up by 5, so we want to make sure that we go up high enough, so that way we include all of our values. As for our dot plot, you're trying to write out how many numbers you have for each of these values, using dots above each of those values to represent how many numbers there were for that particular value. So for instance, for the number 2, we only had 1 2, so we go over to about where 2 would be, and you put 1 dot. So there's only 1 2. Same thing for the 5. A lot of our values here we only had 1 of. We had 1 8. We had 1 12. We had a 15. And a 17. And a 19. We also had a 20. We had 2 22s, so we'd put 1 dot and then another dot right above that. So if you have more than one of a value, you put the dots above each other to represent that you had 2 of those there. Or if you had 3 of them, you'd have 3 dots, that sort of thing. For 23, we had 1 of those. 25, we had 1 of those. Same thing with our 30 was our next number. 32, 33, and then we had 2 35s. So once again, we'd have 2 dots right above each other for the 35. Once again, it's not going to be super accurate since we're not doing this on like graph paper or something. Just want to get an approximation there. So that's what we'd have for our dot plot there using the values from example 1.